step of system design looks like. We'll dive deep dive into that also, but let's just forget all those things. We are building a house for now. So let's just say my requirement is I wanted 4 BHK house. There should be a very green garden over there in the front, and I wanted 2 car parking, a solar panel on the roof, and a modern facade design pattern everywhere in my room, in the ceiling, in my drawing room, in my kitchen, and a kitchen should be modular and everything. Correct or not? So these are my requirements. What will be the next thing? As I told you, write down your requirements. The things that you are visualizing is not enough. You need to write down, okay, hey, 4 bedroom, 3 bathroom, 1 kitchen, and a garden with 2 car parking, and modern facade design and elevated design. This is your requirement. So write it down. So in software also, this becomes your features list. Whatever features you wanted, what will be your scalability, latency, how much budget you have, cost, reliability, and so on. Multiple goals are there. Don't worry about that. What is scalability, latency, cost, and everything? We'll talk separately over there. But this is what I'm talking about, the idea. Clear, everyone? How well it must work. It should be survived during the earthquake. What are the things are there? These are my requirements. But there are few more certain things. It should at least last 50 years or 100 years. It should survive the earthquake and storms. It should be cool during the uh, summer. It should be hot during the winter. It should have a low electricity bill built in this budget, and whatever the duration you wanted, multiple things we had. So these are the functional requirements. Hey, I wanted 4 bedrooms, I wanted 3 bathroom, I wanted these things. These are your non-functional requirements. Hey, I am not writing it a functional requirement, but this is also required. Correct or not? Let's just say a very strong storm comes, your house collapses. This is not you wanted. Correct or not? So a proper building material should be chosen to survive during these situations. Similarly, we do during the software also. Okay, hey, what if a system is down? What if a laptop or computer, the cloud computer where my software was running went down, and multiple things got broken? In those situations, what is going to happen? Whether my software will keep servicing or it will collapse. That is the idea. So we had two type of requirement. First, functional requirement that is much needed, and there is a non-functional requirement that are needed but not primarily, but as much required as the functional requirement also. Clear? So you have a thought, convert into a requirement. Then you give that requirement to the architect. So when you're learning system design, you will be architect actually, right? So you will be a software architect who designs, कि, hey, let's say in building of house, कि, hey, this will be my garage, there will be a bedroom 2, bedroom 1 will be right here, this will be my washroom, this will be kitchen, this will be reading living area, and from here it will be a design. So whatever architects or the blueprint that you design, that is called as a architect of designing or the HM. Clear, everyone? This is the idea. That's how it works. Even if you're planning a house, you need a plan, proper plan, blueprint, and everything. Correct? What next comes? Only now do you build. Yes. After that, whatever requirements you had, clarify non-functional requirement, functional requirement. You lay down the design. Hey, my bedroom will be right here, my washroom will be right here, drawing room will be here, kitchen will be here, this is will connected, and so on. Now building is the last step actually. So now you will start building right here. Not even the blueprint itself is enough. Now you need to think of, hey, there is a blueprint now I designed. Now I'll go for buying a land, then hire a builder, construct, and move into that house. Correct or not, everyone? Are you getting what I'm trying to say? This is the complete flow for the planning a house, right? I'm not teaching you system design. I am planning you what is called as a planning. I'm teaching you what is a planning actually. That is required everywhere. And the same planning, same thing we do in the software industry as well. Okay, this is the idea. What if you skip design? If you skip the design, what is going to happen? Kitchen will build with no water pipe. Let's say you build a kitchen, you skip the planning properly, you design the kitchen over there, but there is no water supply into your kitchen. You will not be able to cook the food, right? Stairs that leads to a wall. You wanted to go to first floor, but stairs that is not complete. It will just end up towards any single wall, right? Tear down, a huge cost you will be paying. Builder argues, nobody is aligned. Builder is thinking something else. You are thinking something else. House cannot add floors later because it is not properly designed. Correct? With design, if you have a proper design, everything fits in first time. Change changes are cheaper on paper. Teams are share on the clear pictures when you design on paper. If you explain in the paper, well, okay, this is what I wanted. You can change the design in paper. Okay, hey, this is not suitable for me. Can we go into the new design? When you are doing a paper, it doesn't cost you anything. You are discussing it properly. Once if you start building, then you wanted to change, you broke that. You have wasted your money and so on. Build to extend and scale it later on. Let's just say right now you're a family of four, so you needed 4 BHK. Later on, you also get married. You have your wife, you have your kids. Now kids wanted a separate room. You need to extend that. You need to scale that. Hey, I have two kids. Now I wanted to scale it to 6 BHK. How can I scale it? You need to add two more BHK into the same. Correct or not? Maybe your kid has one car also. Maybe in future he or she wanted to buy a car, then you wanted to have one more car parking. How you're going to extend that car parking as well? You needed multiple things. Correct? The cost of fixing flaw glows to 10x every stage. Correct? Whatever flaws you have, if you try to fix it, it will take a lot of cost. The cheapest on whiteboard. Just do a whiteboarding, do in pen and paper, and in production it will be very very brutal, very very costly to you, right? This is the idea. So house versus software. What are the similarities are there? Now just we learn. Of course, you guys know more than me how how house designing works. So you guys can visualize it. We need a proper planning, proper execution, everything. Then only we can build a house. Correct. Same goes to the software. So there is a common thing in both. What are the common things are there? Building a house, building a software. Picture of the dream house. Whatever you are thinking of, just picture it. Thought is hey, how you are visualizing it. Understand the product vision. Whatever your product is, hey, I am going to target college students, adults, only teachers, only business person, whom you are going to target the audience. Whether your audience is Gen Z, young, whatever your audience is there, you have a vision of your product. Okay, I'm building a product for college, so it should be ERP, similar to the ERP. If you are building something, let's just say payment system, a payment gateway, a payment application like phone pay, google pay, or if you are building a Gmail service similar to the Gmail, are you building a movie booking application, or you will are you building a food ordering service like Swiggy or Zomato? What you are building, what your vision is there. So whatever your deep picture of your house looks like, similar to the software, whatever your vision of a product is, what project you are building, what vision you have. Then list the number of rooms and amenities you wanted. Then we list number of functional requirement and the feature we wanted. Let's just see, if you're building a movie booking application, you wanted, hey, user should first come to my website, log in into that website. If it is had not been registered previously, it should be registered. If it is coming for the first time, after registering, it will land to the home page. In the home page, it will look list of all the movies that are in my current city. Let's say in Coimbatore, I'm able to see multiple movies, Puspa 2, Dhamal 4, multiple movies are there. Just shows the list, and after that you should be able to choose a movie. Okay, in this theater I want to watch this movie. Just proceed ahead, make a payment. Once you have made the payment, you can download the ticket. You can go and visit the nearest or whatever book the movie theater is. Go there, show the ticket, and you will able to watch the movie. Correct or not? So first you need to list down whatever your functional requirements and the features are there. It should be earthquake earthquake proof, low bills, and should have enough to handle very very heavy storms and all. So these are my requirements in constructing the when constructing the house. And then the similar thing, we have something called a non-functional requirement. Okay, hey, the scalability should be there. If 10 people are coming, it should be able to handle. If 1 million people are coming in my software, it should be able to handle that also. The latency should be very low. Latency means that whenever user clicks www.mymoviebooking.com, it should instantly it should load. It should not show, okay, hey, it is still loading. It should not happening. And the cost should be very very less to you. Let's say you are the owner of that website, it should not like, hey, it cost you millions of dollar, billions of dollar, but you are earning only thousands of dollar, right? Otherwise you will be making a lot of loss into that. So it should be a profitable also. Then architect's blueprint, whatever architects you design, hey, this is how my house bedroom and all those things looks like. There will be a gate, there will be a stair, there will be a wall, ceiling, false ceiling, and all those things you design in your blueprint. Similarly, we have something called the system design or architect design. Okay, hey, I will be using money stack, and then I will be hosting into AWS. Then I will be using something called the API gateway, load balancer, and I will be using MongoDB as a database. I will be using caching for the Redis for the caching, and so on. We think of that, correct? Similar thing we have. Then what are the things needed? We need in a house, we need a land, a cement is needed, piping is needed, wiring is needed, and all those things. Similarly, we can think of what is the server needed, what are the databases needed, do we need queue mechanism or not, we need caching or not. Similar things we have, right? Then construction crew is needed, whom you are going to give the contract. Alone you cannot start building a house. Okay, hey, I will go buy a bricks, I will buy cement, I will buy concrete and all those things, and I will start putting all those things myself only. Alone you cannot do that. You need a crew, you need a basically constructor, or someone who can take the contract and who can build the house, right? And engineering team writing code is needed in software. So when we have all these things designed by senior software engineers and all those, then we'll be having SD1, SD2 developers who will be start writing the code one by one, piece by piece, service by service, and class by class, correct or not? They will start write the code. That is the idea. Then if you are looking into, hey, in terms of a house, let's just say you want to add a new floor, a new 1 bhk or something, a new room into your house 5 year in the future, later on in the future, you should be able to do that. You should be able to scale your house. Similarly, we have right now whatever code we write, that is able to handle thousands of requests in 1 second. But in future, suppose demand grows on and you wanted to handle millions of requests, billions of requests, you should be able to scale to that number also. So these are the similarities building house versus building a software. Clear, everyone? Clear? That's why it is required. Everything, whatever you do, a planning, a proper execution, a proper planning is required. And what part you will be building first, what will be part will be building the last, and all those things should be written somewhere. And that should be aligned by everyone. Let's just say 10 people are there, that should be aware by everyone. That is the idea. Clear? What next we have? So, what is the system design? Now you guys can tell me. Now we have seen what is planning, what is how to plan, how similarities are there and everything. You guys know what does it mean by building a system, or what does it mean by system design. This is the process of designing architecture, component, data flow of a software system that meets the requirements before and as you build it. Correct or not, everyone? What is a system design? A process of defining the component, architecture, and the data flow, and all those things, whatever meets your requirement for a software that you are designing. Correct, everyone? There will be multiple components, like we have rooms in your house. Similarly, we'll have services, databases, caching algorithm, caching mechanism, and caching services. Then the connections will be hallways. Okay, hey, how you are going to go is and stairs for the second floor. Similarly, however data is going to flow, we have a one service for the user service. Then there will be there will be a movie service. Let's just say there will be payment service. So how all those services are connected? What will be the payload for the first service, and what are the out will be the second service, and so on. Then there will be something called a trade-off. Trade-off, which means you are trying to design and you are trying to compromise it between one and two. Let's just say you wanted, okay, hey, my system should be very, very good, but I have a limited budget. Then you can say, okay, hey, instead of going for very heavy data like DynamoDB or MariaDB, something like that, I will be using MongoDB, which is a bit of less costly. Correct or not? So it's comparison. It's basically trade-off between cost versus speed versus scale. Correct or not, everyone? So there is no perfect design at all. It's saying there is no perfect design. It's just you are trying to fulfill the requirement. Only the right fit for your requirements and the constraint. Clear? There is no perfect design. Whatever system design you can build, someone can come and comment on, hey, this is not a perfect one. Instead of using MongoDB, we could have used, let's just say, Postgres or someone else. But you can defend, hey, if I'll be using Postgres, then there will be a much higher cost. But instead that, to want to save the cost because of my budget, I used MongoDB. So it's called the trade-off. When there are two choices, but you choose one on top of another because of some reasons, that is called as a trade-off. Clear, everyone? This is the why it matters, why we need to design, why it is important. It saves a lot of money. When you do prior planning, you build only once. You don't like, hey, you given the instructors, hey, engineers, go ahead, build this, and later on you came back, hey, engineers, we have done something wrong. Can we remove the previous code and can we start writing again from the scratch? Then it will be cost you a lot of money. Why it will cost? Because you're paying extra money to those software engineers, right? They will, whatever they was building, let's just say for the 10 days they was building something else. Now you discarded it. For those 10 days you paid extra salary to them. Correct? And it is scales well. So if you design in growth, and it will be painful writing in future or re-evolving into the future. Right, in thinking of, hey, in future how I can scale it. Aligns with the team. Everyone aligns in the same thing, same pace. Everyone knows what is my task, what I have to do, and what others are doing, and what is required to do best in my part, and survives in the failure. So when there is a electricity outage, when there is some services down, when something bad games, during those times your solution should be, your services should be survive. Let's just say you go to amazon.com, you wanted to buy a book. Let's just say your exam is near the corner. Let's say after 1 month or something you have your exam. Now you are buying a book, hey, how to learn system design, you are going to buy a book and Amazon is down. What you will be able to say, hey, this Amazon is not a good service, Amazon is not a good website, whenever I try to buy something it is down. So it will lose a lot of money, it will lose the customer trust also. So it should survive during the failure times also. It should be predictable means whatever you're thinking of, it should be into the same place. Correct, everyone? This is the idea of this one. That's why it matters a lot. Whatever software you're designing, it matters how you're designing, it matters proper planning, it matters before system designing, it matters how you're going to execute it. Interviews. So, whatever, let's just say you're going to hire someone to design your system, you know what are the requirements. Based on that, you can hire the team as well. Correct, everyone? Right? This is the idea. Cool, everyone? All right. So this is the idea. So it saves you a lot of money. It scales well in future. It's aligned with the team. It survived during the failures. It is predictable. What are we predicting? Let's just say I was predicting my software is going to cost me $1,000 a month. It is not costing more than that. it was expected to you should so that you have a budget of $1,000. If you spend more, then you will be losing money, right? You will be getting out of, hey, this software is not reliable, nobody is buying because it is so much of costly. Correct. So how much design is enough? Even sometimes software engineers say, hey, nowadays if you know system design, you should know also how much design I need to do that also. It's not about I spend 1 month on designing itself and it takes 1 month and I over engineer it and it is costing me a lot. So when you are building a house of a very small house for your pet, a dog house or something you are building, you just know I just need to spend 20 minutes. Hey, there should be a simple home. This will be, let's just say, 4 by 5 feet. There should be an entry gate into the middle, and there should be two basically bowls, one for eating, one for drinking. That's what you needed, right? Just 20 minutes is enough to design a house. But 1 to 2 days is enough to design a home. Let's just say you're building a home for yourself, real app. So just a proper sketching. Hey, how many bedrooms are there? Where will the bedroom? Where will be putting your bed? Where will be your entry gate? And where will be your washroom gate? And where will be washroom? What will be the dimensions of your bedroom or dimensions of kitchen, dimensions of dining room, dimensions of washroom and entry gate and all those things? It takes 1 to 2 days. But when you are building skyscrapers, let's just say you're building Burj Khalifa or something, you need maybe years of discussion, designing, proper visualization, requirements, and multiple things. Maybe it takes years. Correct or not? Because it's, let's just say you miss one small thing. In one room, you forget to put a single pipe for the water, or maybe you is missed to wire the things properly, how electricity goes to this room, then it will be a very blunder to see, hey, out of these 280 room or 1,000 room, there is a one room which is not having access to the water, not having access to the electricity. That's why a proper planning is needed when you are building a system for the millions of people. Yes or no, everyone? So make sure whatever you're designing, that designing is not over engineered, not even less engineered. Whether it is not able to fulfill the requirements, but you over engineer it so much it is costing you a lot. You're paying a lot of cloud bills. Your requests are taking a lot of time because you have inbuilt into multiple services, and those services taking request and taking time to return the responses. Yes or no, everyone? These are the things that we need to take into the mind. So match the rigor to the sketch. Over designing a small thing, don't waste the time. Under designing is a big thing that sinks it later. Clear, everyone? This is the idea. Now the idea is that design first and then build once. Whatever we learn, that we learn in perspective of planning a building house. But the same thing you have to do when you are trying to build a software. A very simple example I given to you. If you want to reach your college, you need to wake up by 6 or 6:30 so that you can reach your college by 8:30. How? You need to wake up by 6:30, teeth your brush, take a bath, have your breakfast, pack your stuff, reach to the pickup point by 7:30 so that a bus can pick you up, and then you travel for the 60 minutes and then you reach to the college on time. That's how it works. That is also planning. The same goes for building a house. You plan it, visualize it, write down the requirements, go to the architecture based on your requirement. Architecture designs are 2D and the 3D of your house. Then you give in to your contractor, and contractor builds it, and you moves into your new house. Yes on everyone? Clear? That is idea. Same we achieve into the software development with the help of system design. System design has multiple parts of it. There is something called the OOPS, there is something called the solid principle, the design patterns are there. In fact, these things are also divided into something called as a HLD and LLD. There is one thing called as the LLD, one thing called as a HLD, and so on. Clear, everyone? Okay. Any questions so far? If you have, you can put into the chat. I hope I was able to tell you how important system design is nowadays. Correct or not? Why it is important, how important it is, why you should learn. I hope I have answered all those questions. Now let's jump towards the software, or basically system design. Okay, cool. If there is any questions, please let me know. Otherwise, we'll jump towards the next part of if learning what is system design, what are the parts are there, how we can move ahead. Clear, everyone? Clear, everyone? Cool. If there is any questions that you have, please let me know. Otherwise, we'll move ahead. Okay, so most of you, I'm expecting you have joined through your present, basically what I can say, projector in your classroom. So you might not be able to ask the questions right here, but if you have joined through your laptop, personal laptop or something, you can put it into the questions. Else, we'll move ahead. So that's it for this one. Let's move towards the building blocks of system design. We know what is system design, why it is important. Now what does it mean by what are the parts are there, what is the building block of system design are there. Let's deep dive into those things there. Clear? Clear, everyone? So, as you know, there is something called LB means load balancer, DB means databases, caching is basically that comes between the databases, queuing is basically when you cannot the fulfill requirements right now, you put into the queue, okay, hey, later on your request is going to be your request is going to be successfully return the response, and what is the API, that all those things comes into your under the system design. And there is a concept called the oops, then solid principle, human diagram is there, design patterns are there, databases and multiple things are there. So that's what we are going to learn into the further next lesson. So let's talk about this much, from blueprint to the bricks. What is in by the bricks? When you are building the home, you are building one by one, you are putting the bricks, and then you will be getting your home. So how many parts are there of a system design? When you are designing a system, first you should know four pillars of object oriented programming, that are nothing but encapsulation, abstraction, inheritance, and the polymorphism. You should know whatever your code you are writing. Of course, you will be writing in any of your programming language. Either you are going with the Java or the C++, Python, JavaScript, or whatever. So, whatever you are writing, all those languages support something called as object-oriented programming, where we deal with the classes and the objects. Clear? Clear, everyone? Then there are some solid principle. These are the rules that you should follow so that your designs are scalable into the future, so that they are more into resilience during the failure, and it can serve to the millions of people. When you learn something called the oops and the solid principle is the part of LLD, we can say. Then there is a two things, something called the HLD and LLD. HLD is your high level design, LLD is basically low level design. When you're thinking of HLD is basically you're looking from the top, what are the blocks will be, what are the services will be, right? When you're thinking of LLD, you're picking up one particular service and writing a code for that particular service. In terms of house, you can think of HLD is the overall structure. Okay, hey, there will be a house. Overall house consists of one basically a drawing room, one kitchen, one washroom, one bedroom in the ground floor, and then the three bedrooms with attached washroom into the second floor. That is your HLD. But when you think of how your drawing room is look like, okay, in drawing room will be a 40 by 20 by area. In one corner there will be a couch. In another corner there will be a sofa, come bed, and in another corner will be having some of the games and some of the books over there in one rack or something, and in another corner you will be having your TV, there is this space will be, let's say a proper space will be for the 43-inch of TV, and then by the side, both the side, there will be some sound bars and all those things and stuffs you can think of, that will be the part of LLD. So HLD is looking from the top what are the things are needed in one particular thing, go ahead and deep down and write the code that how will be executed, that is called as a HLD. And in so that is called as a LLD. In LLD, how other things are connected, you have designed LLD for the drawing room, let's say, from where the kitchen will be connected, how kitchen will be connected, what will be the entrance area, like 3 feet in the width and 6 feet into the height, there will be a door which goes directly to your kitchen, and this is how your kitchen will be connected, and there will be a washroom which is also going to be connected to your drawing room. That the flow that you define, hey, from here I will be giving the gate to this place, from there it will be a main entrance, and then here it will be I stay to the first floor, and so on. Whatever you can think of, that we use something called a UML diagram. So there is something called a UML diagram. You design the flow for LLD, how one class is connected to another class, what is the relation between the class, and what will be your arguments, what will be your parameters, what will be your basically data members of a class, whether the class will be public or the private or the protected, and all those things that you define, that is comes under the UML diagram. Then there's something called the caching and the queuing and the database. Then something called the microservice architecture. Hey, I will be splitting my service into the monolithic architecture or the microservice architecture. In microservices, multiple service, what are the services are needed. Then you will think of scaling also. Okay, how will be scaling? Let's just say something happens and one service is down, or once you want to replicate the one more service of the same service. Let's just you have a service, something as a payment service is not able to process the payment of all the users, you want to duplicate it. Okay, hey, I will be having two payment services, then the reliability, when there is a failure or something, it still serves the purpose. That is something called as a this part. Then what are the four pillars of OOPS? I told you: encapsulation, abstraction, inheritance, and the polymorphism. These are the four things that you need to keep in mind when you're talking about the object oriented program. What is the encapsulation? Bundling the things that we have seen the capsule. Correct? You get a capsule, let's just say, of fever, let's just say, it has multiple components, say the magnesium, calcium, a pinch of painkiller, and all those things, and a bundle it one thing and given to you during your fever. Correct or not? It has multiple components of it. Similarly, when you have multiple things and you combine them together, that is called the encapsulation. The class itself is an example of encapsulation, right? You bundle your data members, you have data members over there, you have your multiple methods, and you bundle them in a class, and now you can call create an object of that class, and you will be access to all those things you bundled in a class. That is called encapsulation. What is the abstractions? You can say, hey, you just know how to do it the things, look how to you don't know exactly how internally it works, but you just know, okay, if I'll do this, it works. It if there is a class, you call the class, hey, I want to create a new car, you will just say, hey, car equals to new car, and a new car is going to be created. You don't know how this car has been created. That is abstraction for you. That is called as abstraction. You don't explain or you don't expose everything internal working, all those things, but you just explain, hey, just take this and it will work the way you expect. That is called abstraction. What is inheritance? When there are two classes, one is a class and another is subclass of the upper class. So the property of upper class or the super class get inherited to the lower class, that is called as the inheritance. And then there is a polymorphism. There are multiple methods, choose the right one, which one to the execute, whether it can be happening when you are in the lower class, there is a method, same method in lower class also, same method in our class also, you call, and it gets called to the upper class when it required, it gets to the call to the lower class when it requires. Or in the same, you have just a different function definition, and it is getting called according to the function arguments, and you will, that is called as a polymorphism. So poly means multi. So basically there is a one function, there is a multiple function with the same name, but the signature is different. And when you are trying to call to one, the particular one is getting executed, that one you was expecting. That is called as a this one. Correct, everyone? Then there is something next that we need to do. So these are the four pillars of your object oriented programming. Then there are five design rules that we call it a solid principle actually. So these are the rules for the clear design. Solid principle stands, S stands for is single responsibility principle. There is a one class, you should be having one region or one basically responsibility to perform. So let's just you are building a car, so there should be a car class that is responsible for building a car only. Let's just say you want to build a wheel, then there should be separate class to build a wheel. You cannot say, hey car, can you build a wheel, and car is building the wheel itself. Car is building the truck itself. Car is building a bus itself. There should be separate classes for separate responsibility. So single reference for single responsibility principle on this one. So in next further classes, you should be deep diving into the what is in a single and how you can define those things, how a Java code look like. I'm just giving an overview of solid principle over here. In the next further classes, you will be getting deep dive into those things as well. Then there is something called the open close principle. Open close principle means open for extension but the close for modifications. That instance I'll explain into the future classes. What does it mean by, how does it looks like in code, I'll explain with the help of code itself. But this is the idea. Then something called a subset list of substitution. A subtype must work anywhere with its base. All right, so basically in one thing you have created, and from one class if you have created another class of subclass, if you substitute the data members of the methods are from upper class to lower class to the upper, they should work properly. That is called a list of substitution method. Then there is something called the interface segregation method. So interfaces should be separate. So basically when there are some common things into multiple classes, let's say we have a class A and class B. Class A and class B are having some common methods, common data members, then and common methods actually, common behaviors actually. Then it should be creating an interface which is a common for both the classes, and that interface will be implemented by both the classes, and automatically it has both the common behaviors or the data members. Then there is something of the dependency inversion. The idea is that the lower classes should not dependent upon the upper classes. This is the idea of dependency inversion. Dependency dependent on abstraction, not on concretion. This is the idea of solid principle. Then there are two things. As I told you guys, there are two things. One is HLD, one is LLD. I told you whole state is something called a HLD. When you are looking from the top, from the high level, hey, this is how my house is going to look like. These are my rooms look like. These are my things going to be there in a thing, that is called as a high level. How many services you needed, how many boundaries you needed, how many data flows, how data is going to flow between the multiple system, what are the databases you are going to use, how many caching algorithm you use, where are your caching lies, how many queues, and what are the things that will be going to create. That is something are there. That comes who designs these part actually are architects. Then there is a single room. I told you guys an example with the house. If you're thinking about just single room, how your single room is look like, that is called as a LLD. In terms of class, in terms of software development, we can say when you're designing, hey, how one classes looks like, what are the methods are going to be, how your interface is going to be, which design pattern you are going to use, which type of schemas you are going to use, what is the API, which API is going to hit or create the object of this class, and all those things that is going to be developed by developers. Actually, this part is going to belong to us as a software engineers. This part is belong to someone, either the senior engineer or the software architect. Correct? This is the idea. So what we do, as I told you, there is something called the UML diagram, unified data model diagram, something called is there. unified data model diagram is there, UML is something there. So basically, this, suppose this is a class, let's just say house class is there, I can say, okay, in house I will be saying, hey, there will be integer type room variable is there, which is going to store how many rooms are there. And there will be another integer which is going to say, okay, how much area of my house is going to be there. Then there will be two methods, okay, add room and basically some value is there. So this is how your class is going to look like. There will be multiple classes. This is house class, then will be a room class, then will be a washroom class, and let's say dining room class is there, and multiple those classes are there. So how one class is connected to each other, you can explain through UML. So this is basically a shared visual language. The architecture, the architects draw the code actually. So this is how it looks like. So first owner has the idea, then owners gives those requirement, functional requirement, non-functional requirement, the builders build it exact that how it looks like in HLD part, then crew member goes for the LLD. This is the idea, who talks to whom in order, and everything is sequence and everything is going to be there. That is called the UML diagram. Then there are multiple design patterns I told you in basically LLD part. There are multiple design pattern. So this is something called as a single day design pattern, factory design pattern, builder design pattern are there. Then adapter, facet, proxy, and then observer, strategy, command. These multiple design patterns are there. Correct or not, everyone? So this is how design patterns we are going to use. With the help of these design patterns, not necessarily you will be using all these design pattern in your class, but the idea there is there, let's say one or two design pattern or the three design pattern are getting used into a class, into a single class, and other design patterns are getting used into other classes, and so on. But we should be learning in this into LLD part of your lecture. Clear, everyone? So basically, when you have a caching, so it the request hits fast. It just go to the caching and comes back. But when you have something called the without caching, it goes here, then goes to the database, comes back and gives back to you. That is called as something called a caching. So that's it. I think I just want to show one more thing right here. This is the HLD diagram of, I'm not talking about you should be learning this, you should be know this and all. Don't worry about this. This part is going to be explained in a separate topic itself. So you need 4 to 5 lectures for the LLD, you need 4 to 5 lectures for the HLD. It's just the introduction of both of these things. It's just the introduction class. What does it mean by LLD? What does it mean by HLD? So I'm explaining everything right here. Is my audio breaking it to you guys, or everything is clear? Is my screen visible? Am I audible and everything looks clear to you guys? I can see my screen, my audio, my video is a bit lagging. So I'm asking, okay, clear? Okay, thanks. Thanks for the confirmation. So basically, I have taken this an example of movie booking application or a event booking application similar to the Book My Show. Okay, this is an example. So I will show you how HLD of a software or a system design look like. This is the idea. So first off, a user comes into the picture. Who is the user? User is basically you and me. Whoever send a request to the Chrome. So let's just say I want to go book my show. I am clicking is right here. So I am the user. If I'm clicking to this URL, I become, my browser become as a user. Correct or not? So these are users. So first my request, when I'm clicking into this place behind the scene first goes to the API gateway. What is the API gateway? This is a single front door. It authenticate the user, enforce the rate limit, and route the request to the each, and the right service also balances the load between the multiple service. So you can see for the first time I landed it right here. If I'll try to book, hey, just say, let's just say some book some movie is there. I don't know which movie to look for. Which movie we should go for, guys? Indian Ocean, Rock on Harish. Multiple things are there. Let's just say I'll go for the movie, and I'll go for this Ma Inti Bangaram. Let's just say this one movie I wanted to watch. So if I'll try to book this movie, book a ticket, I'll choose the cinema. I'll go ahead. I'll book these two seats. Let's just say. So first, it let me do everything, but now it will ask me to register and all. Look, this is asking me contact detail and all. Correct or not, everyone? So the idea is that first, whenever users comes, it should go to the load balancer, and load balancer decides which type of request is that. Focus back again, guys, when I was in home page. So I landed in home page. Now I'm clicking into the movie. It should go back to the movie service. Okay, it should be go to the search service, right or not? So that I can search which type of movie I'm talking about. So let's just say I am talking about this movie. I have searched it. So I went to the search service right here. I went as a user, I send a request, is go to the API balance. API went send to the load balancer, and this load balancer send me to the search service. Hey, you can search about it. Yes on everyone. After searching, if I'm going to book the movie, then it shows it should go the request should go to the booking service. Correct or not? From the booking service, I'll start on booking. I watch the Telugu movie. I'll choose the tickets and all those things. And after that, I'll move ahead. Now, when I came here, if I am not registered, then it should be sending to the user service, okay, hey, can you register yourself? Once I will be registered right here, then it will direct me to payment service. Once I have done the payment, my payment will be stored into the payment database, and I will be getting requests back to saying, okay, hey, here is your ticket, and this is how you should able to book the movie and complete the flow of it. Yes or no, everyone? Is there any question that you have? Am I audible to you all? Clear? Madhushri, can you confirm this? Clear? Everyone? All right, looks clear. So now I'll show you the flow. I have just created this animation so that you know when you just comes here and then how it travels your request. Whatever request I'm sending, it looks like to me very fast here in the front end. But whenever I'm clicking, whenever I'm mixing performing, it request to the you can look into the browser. It will always look a different. It will always go to the different URL. Means I'm right here, it looks for explore then movie Bangalore. If I'm clicking right here, it goes to this place. If I'm clicking right here, it is going to look into this unique path, right or not? Every time when I'm clicking something right here, when I'm clicking counting, it just hit to that unique URL. Unique URL means sometime, majority of the time, it goes to different services. Each service is responsible for one single task. The user service is responsible for creating the user account or the authentication or the authorization or saving the data of a user. How many data you have, what is your payment gateway, what is your email ID, phone number, and all those things are getting stored. Event is basically storing movie details, event details, whatever events are going on, whatever movies are going on, that will be stored right here, and that will be handled by event service. Then the search service is actually performing the search. Whatever search you do, it looks into the event database and search and gives you back the result. And then there is a movie booking service from where you can book the details, book a movie, and all those things will be done by this service. So let me play this animation. Right now the user was right here. From API to load balancer, booking service, then goes to the search. After searching, payment service, payment done, notifies to the user and says, hey, you have done the payment, and from the Kafka return back to the user. This is how the flow. You go from here to here, from here, and then goes, says the queue, the request, comes the payment, payment gateway takes the payment, you notifies to the service, and the users also send an email and all, and comes back again and then goes to the user. This is how it looks like. Look the flow, and so on. So these are actions happening when I'm booking a movie. I will land to the home page, and whatever action I'm performing, almost similar happens into the book my show itself. Whatever I shown here, right here, this complete flow happens in behind the scene of any application, a similar application, any of the application, similarly it happens. Now this is HLD, high level design diagram. This is high level of event booking service, event booking platform, correct? Now if you talk about the what is low level, then so if I'll talk about, hey, how your user services look like, what will be the code inside user service, that is LLD, low level design. What will be the code inside your event service, that is called the LLD. And how this event service is connected to the user service, that is data flow, correct or not? How these two classes are going to be connected, that is the data flow, correct or not everyone? This is how it works into all the system. Clear everyone? Any doubt so far? So if you go to what is API gateway, you will get it. What is load balancer, you will get it. What is load balancer? What is search service? You will say, hey, search service is a find event backed by search index, basically elastic index, elastic search kind of a database we'll be using right here, and kept in sync with the event DB via sync service. So no queries, so the queries are fast and full index. If you look into the database, it says each service has its own database, and this is a single source of truth. This keeps the service decoupled. One can change its schema without breaking it. What is the notification service? Listen to the different events across the system. Whatever event you are performing, if you are booking a movie, if you are doing anything into the event, it just captures it and send email to the user if you have booked the email and all. So this is something called as a notification service. Then what is the event service? Managing the event when you show times, seat inventory, publishes the changes, and queue so the search and the recommendation stays the fresh. So each service, it explains everything well here. Okay, looks like I lost the connection in between. Okay, so in the next classes, we will be start talking about the design patterns. Even before that, we'll talk about the solid principle actually. From here onwards, we start. We'll see what is a single responsibility principle. We'll write the code. We'll see how it looks like in a code. And same goes for the open course principle, list of substitution, interface segregation, dependency inversion. Once we are done with the solid, oops, you have to cover yourself. These four things you have to cover yourself. The homework for today is to you guys, cover the oops topic your own. Just from the solid principle we'll talk about in the next classes onwards. Oops will talk, and then we'll talk about design patterns, and then HLD, LLD, and everything is we are going to talk about. Then we'll also do design pattern, and after the design pattern, we'll see this is the caching is part of HLD design. So we'll talk about that as well. Clear? If there's a caching, it takes very fast, goes and comes back. If there is no caching, goes, then go to database, comes back, and then comes. So it takes slow. These are the idea of this one. Then we'll talk about the databases versus SQL versus NoSQL, then messaging queue, what are the queues are there, then microservices, like monolith versus microservice architecture, what is a scaling up, scaling out, and all those things we'll talk about. And also design failures, what are the things we can think, observe, what it can fail in future, like redundancy, circuit breaker, observability, auto scaling, multi-region, and graceful irrigation, and multiple those things are there. And this we talked about this one as well. All right, done for the day, guys. If you have any questions, put your questions into the chat box. Otherwise, we are done for the day. In the next further classes, we'll talk about more. These slides will be shared with you in your respective WhatsApp group, so don't worry about that. Cool. I will be sharing our folder itself. Over there, you will find HTML, CSS, JavaScript file. Just open the HTML file. You will able to run these things your own. Clear, everyone? All right. Thanks for the day, everyone. If you have any questions, please let me know. Otherwise, we can close this session right here. All right, everyone. So I'm closing this session. I'm assuming if you have any questions or query or something, you can put in your WhatsApp groups. From there, if it can reach it to me, I'll answer your queries. I'll happy to answer those. Thanks, everyone. Let's meet into the future sessions. Bye bye. Yep. Thank you, everyone. All right.